Today we are discussing about effective Coriolis force on a freely falling body. In last class we derived an expression for Coriolis force, and now we have good idea about what is Coriolis force and what is its equation, right? And also in last class we said the earth is a very good example for rotating frame of reference, right? Yes, please consider this is our earth and this is the central point. North, south, west, east, and this point can be represented by the letter A, and we consider at a time equal to 0 an object with a mass m is placed at this point A, and we will allow this object to free fall. Then we expect after a time t, the object will fall on the surface of the earth, and that point can be represented by the letter B. So please consider after time t the mass will touch at the point B, and this angle can be represented by phi, right? So the velocity of the object, those have mass m, is freely falling from the point A, and we expect after time t the object will touch at the point B, and the velocity of the freely falling object can be write v is equal to minus v k, because the object is moving downward direction. So we can represent the velocity by using minus sign, and here the k is unit vector. This is the vertical direction, and k is the unit vector. In same way, earth have a velocity because the earth is rotating its own axis. So earth have a angular velocity. That angular velocity can be represented by omega, and we can able to split this omega in the term of unit vector k and j. This is the vector j, unit vector j, towards the direction of north. So the omega can be split in two terms. One is in the form of k vector, that is in vertical direction, and another one is in horizontal direction, that is in the term of j vector. So we can write omega is equal to omega cos phi j cap plus omega sin phi k cap. Okay, then we derived an expression for Coriolis force. in last class. What is that equation? That equation is the Coriolis force Fc, C for Coriolis is F for force. So Fc represent the Coriolis force. So Coriolis force Fc is equal to minus 2m omega cross V. Here we know the value of omega, that is omega cos phi j plus omega sin phi k cap, and we already get the value of V. What is V? Minus V k cap. Now we can substitute this value of omega and V in this equation. Then Fc is equal to minus 2m omega cos phi j cap plus omega sin phi k cap cross, what is V? Minus V k cap. Now we can multiply this term by using minus V k cap. What we got from this equation? Fc is equal to minus 2m minus V omega cos phi minus V omega cos phi j cap cross k cap, j cap cross k cap plus minus V omega sin phi k cap cross k cap, minus V into omega sin phi k cap cross k cap, and we already clear k cap cross k cap is equal to 0 and k cap cross j cap is equal to I cap. Then what is get from this equation? See, Fc is equal to minus 2m minus V omega cos phi j cross k, what is I cap, and here minus V omega sin phi k cross k cap cross k cap is equal to 0. Then this term will cancel. So Coriolis force Fc is equal to minus into minus plus, then 2m V omega cos phi I cap. What is Fc? Fc Coriolis force, and this m mass of the object, free falling object, and V velocity of the free falling object, omega the angular velocity of the earth, and phi this angle. And what is I cap represent here? I cap represent the direction of Coriolis force. I cap represent the direction of the Coriolis force acting on the freely falling body. Means actually at time 0 the position of the mass m at the point A and we expect after time t it will touch on the earth's surface, and that point is B. But due to the action of Coriolis force on the object, there is a path deviation and it will touch another part of the earth's surface. Can be represent C, right? Because there is a deviation in the path due to Coriolis force, and the direction of force is I cap. Direction of force is I cap. So this is the I cap direction, means towards the east. So actually we expect after time t the mass will touch at the point B, but in reality due to the Coriolis force there is a path deviation, and after time t the object will touch at the point C. This is the point A and the mass m is free falling. We expect after time t it will reach here, but actually there is a path deviation and it will reach the point C. So there is a path difference in between the point B and C. We can represent it by using the letter X. This is the X. So how can we calculate this value of X or this path difference? Is it possible? Yes, possible. How? To find the value of X, we can use Newton's second law, that is F is equal to ma. What is A? The acceleration of the object. What is acceleration of the object? D square x by dt square. Means if we differentiate the value of displacement with respect to time at twice time, then we got the value of acceleration, right? Then according to Newton, F is equal to ma. M is the mass of the object. So in this case, m is the mass of object, that is m, and a, what is a? We can substitute this value. F is equal to m into d square x by dt square. So how this displacement is happening due to this Coriolis force? So the product of this d square x by dt square into m is equal to Coriolis force. So we can rewrite it as Fc. And what is Fc? We have the value of Fc 2 m v omega cos phi. Here we only consider the magnitude. Then m remaining d square x divided by dt square equal to 2 v omega cos phi. And here we can rewrite the value of v. How? Because v is equal to g into t. Here g, gravitational constant, t, the time taken to free fall. Then if we multiply g with t, we got value of velocity. So d square x dt square is equal to 2 gt omega cos phi. And if phi is equal to 0, this angle becomes 0, then what's the value of d square x by dt square? Cos 0 is equal to 1, then d square x dt square is equal to 2gt omega. 2gt omega. Now we differentiate this equation. Then dx dt is equal to 2g t square by 2 omega. 2 divided by 2, we got g t square omega plus constant. And if the time 0, the position of mass m is at the point A. So at the time 0, there is no displacement, right? Then what's the value of dx by dt? It's become dx by dt become 0 at the time t is equal to 0. That means t is equal to 0, the constant also become 0. At this condition, the value of dx dt is equal to g t square omega. Right? Now, again, we going to differentiate this equation. I just use this place. Okay. Then again integrating this equation. Then we got x is equal to g t cube by 3 omega. Here x equal to g t square become t cube by 3 omega plus another constant d, and in applying the same condition, that is if t is equal to 0, there is no displacement, there is no value of x, means at time 0 the value of x is equal to 0. That means g t cube by 3 omega plus d is equal to 0. What it mean? D become 0. At this condition, we got the value x equal to g t cube by 3 omega. That is x is equal to 1 by 3 g t cube omega. What is g? Gravitational constant. What is omega? Angular velocity of the earth. And what is t? The time taken for the free falling of the body. And how can we calculate the value of t? These two are understood, but in the case of t, how can we calculate? Here we can use the equation v is equal to gt and t is equal to v by g, or t is equal to root of 2zg. What is this z represent? The height of the object, or the distance between the initial position of the object and the surface of earth. For example, if we consider this is a tower, and at the top of the tower we allow an object to free fall, and the height of the tower is 100 meter. So the distance between the point or the object mass m and the surface of earth, that is 100 meter. Then we can substitute the value here. Then we got 2 into 100 root of 2 into 100 divided by g. What is g? 9.8. Then we got the value of t in second. So we can substitute the value of t in this equation, and we will get x is equal to 1 by 3 g 9.8 and the angular velocity of the earth and also the value of t by using this equation, right? Okay, so what we discussed here, effect of Coriolis force on a freely falling body, and we derive an expression for the Coriolis force. What is Coriolis force? Fc is equal to 2 mv omega cos phi I, where m is the mass, v is the velocity, and omega is the angular velocity of the earth, phi is the angle, and I represent the direction of the Coriolis force, and it becomes towards the east. So at the time t is equal to 0, the position of the object at the point A, and we expect it will reach at the point B after time t, but actually in reality, due to the effect of Coriolis force, it will not touch at the point B, it touches at the point C due to this Coriolis force. And also we calculate the displacement or the path difference by using this equation, x equal to 1 by 3 g t cube omega, where x is the path difference, 1 by 3 constant, g is constant, omega and t can be find out by using this equation, t is equal to root 2z by g, right? Okay.